Okay guys, when you have you open Spartan and you go into the upper left hand corner of the file, click on File, then click on New Build, right? And you see this palette over here come open. You can't really do anything unless you open this palette. If you look towards the bottom of the palette, right, what you'll see down there is this button right here, this E, that's the energy minimization. So we talk about energy minimization, that we're talking about. This one right here, the blue and the white, looks like an eraser almost. That's when you delete like one atom or one bond at a time. This one right here is when you break a bond, right? It doesn't make it go away, it just breaks it. And this right here is when you connect two bonds, right? On the end of the yellow tabs, you click them and it makes a bond, okay? So that's hidden kind of down there. Let me point out, right here is smiles. So there'll be times when you can import a smiles and put it right in there. So that's down there. And then here you can see you have your basic functional groups, right? So you have carbon with 4 bonds, carbon with a double bond, single bond, okay? You have over here like oxygen, you know, with 2 bonds like in water, or a double bond like in O2. You have hydrogen over here. Okay, so this is your basic things that you'll build a lot of things with. If you look a little bit above that, right, you'll see this up here, this inorganic, and you can click right below the carbon, right here, click there, you'll see the periodic table. Okay, so if you're going to do, say, something with iron, or you're going to use arsenic, or you're going to use sodium, something like that, that's where you go for it. Okay, so that's there. Let me also point out, so up here, going back up to the top, right, you have organics, that's your basic organics. Inorganic, you can click to your periodic table. You'll also notice here you have some of your odd geometries, you know, like say square planar or the octahedral type thing, okay? You know, linear. So there's some here that you may end up using. Up here you have peptide, right, and here's where you can pick your 20 amino acids, so you don't have to build amino acids one at a time. So let's say, I'm just going to pick a nice easy one. Let's say we're going to make glycine times 5. You click here, glycine, right, go over to the screen, double click, right, and glycine pops up, right? And so it's sitting there, all right, so that's great. Now let's say I want to erase it. I'm going to go down to that eraser on the bottom, the blue and the white box, and then, you know, delete it, you know, one atom at a time, although that's not, every time you hit the eraser, it only lets you delete one thing, so you have to go back there and click it again. Right? That's just how they do it, so you don't accidentally delete big parts of your molecule by accident. Okay, and so I'm getting rid of that. So what you want to do typically is have a sequence, right? So let's say, for example, you have 10 glycines in a row. Okay, what you do is this little box right here, it says sequence, you click that, and then so you have glycine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say it has a cysteine on the end, so I'm going to click there, so that's there. Okay, come over to your box here, double click, right, and you have your amino acid. And remember, the roll in the middle lets you make it a little smaller, so it makes all those peptide bonds for you. So this is not its final geometry. Remember, in that lower right hand corner, you have that icon with the letter E and a red ball. That's the energy one. You're minimizing your energy, so click on that and watch what happens. Right, it rearranges itself right into the lowest energy state that's there. Okay, so what we're going to do is quasar calculations with this. We're going to go up here to the top to setup. Right, so setup is up here, and calculations, setup calculations. Right, and just to show you this real quick, this one right here that says density functional. Okay, so you can leave it open and read what it does, but this is the different programs that you're going to use to calculate parameters. So that right there looks like a picture, and it is, but it has a whole bunch of quantum mechanics behind it. Okay, so we're going to go up here to density functional, and let's say molecular mechanics, the first one at the top there. That's the simplest one, so it will go the fastest. You'll get results back pretty quick, but it's also the most inaccurate, so that's a good for approximations. You typically want to have some better things. You'll also notice that over here on the right side, quasar, right, that's our quantitative structural analysis program, that you can't run that under molecular mechanics. You'll notice up here, it's going to automatically run it in neutral. Okay, you can't click on, you can't run an NMR spectra for it. All you can do is IR or just minimize it. But if you were to hit this, you'd hit submit, and the trade-off, or the good thing about this, is it will come back to you pretty fast. So molecular mechanics is the simplest level. It goes pretty quick. There's some things you can't do with it, and the values you do get aren't super accurate. So let's just hit submit. Right, and it's whatever you want to call it to. So you see here, mine says local, submit to local. I can give you a set of instructions if you want to submit to the cluster. That's the supercomputer we have. So you can name this whatever you want. I'm just going to call it peptide. Right, and then hit save wherever you're going to save it. Right, and now it comes back. It's started. So you hit OK. It should come back pretty fast. All right, so it came back. And now what you want to do is up at the top there, let me move this up just a little bit, you're going to go to display and then properties. So display properties. You'll see output then properties. Okay? Alright, come on, let's go. So right now it's saying not responding. I don't know why. Let me try it again. Let me close that. Oh, so I did something happened with that, so let's just close it. I'm going to reopen Spartan. Rule of thumb, when something doesn't work on a molecule, rather than trying to correct it and spend a lot of time, just close it and open it again. So we're going to go Spartan again. I have a ton of programs open right now, so it might be something like that. So again, File, New Build. Right, I'm going to go over here to peptide, and right next to peptide is nucleic, where you can make single-stranded, double-stranded DNA or RNA or whatnot. So peptide. I remember, so what we're going to do is sequence, and I'll just pick one that's nice and small so it'll go quick, and put it out there. All right, I'm going to hit energy minimize. Okay, and so that's right there. So it's in 3D. Now remember, what you don't want to do is hit buttons real fast, because sometimes when you have a bigger structure, more atoms, it takes longer to do things. So you might want to turn it and then just wait, right? So don't rush it and say, oh, I kept doing this and that. So turn a little bit and wait if that's what you want to do. You can see it has the two ends there, right? The two yellow ends, so you can connect things to that. But when you hit energy minimize, to those ends it automatically attaches hydrogens. All right, so I'm going to go back up here to setup again, calculations. All right, remember what we did was molecular mechanics, right? And I'm going to hit submit. Don't hit OK, hit submit. Okay. So it started. And hit OK. And so we're going to do display properties. Oh, and it came up to the right for me. So I'm just sliding it over so you guys can see it. So you don't get too much data out of this, but one of the things you can check is your empirical formula, right? That's correct. Dipole moments here, right? It's molar mass. And then you go to quasar, and it does give you a couple of values, but you notice that several of them are not given. So hydrogen bond donors down there, right? Hydrogen bond acceptor. Remember those from Lipinski's rules, log P, right? Volume, area, right? And right over here. Thermodynamics it doesn't do. You have to do a higher level. 2D drawing, it typically won't do. Let me make it a little bit smaller. So that's your 2D drawing. I will point out that sometimes the 2D drawings look a little awkward if it's a fairly complex thing. So you do something small, it looks good. Something big, it doesn't look so good. Okay, so that's that. But what we want to do when you do your good runs, you're going to do setup calculations. Okay, molecular mechanics. You're not going to do molecular mechanics. You're going to do semi-empirical. So what semi-empirical means, it combines some existing experimental data that they loaded in here with calculated values, right? So it's a blend of computational and experiment. Okay. So this has a total charge to the right of 0, right? So if you did something, say sodium +1, you would change that to cation. Right, if you had calcium +2, you would change it to dication, right? And I'm going to click quasar, okay, because that's what we're after. Don't just start clicking. Let's say all of these were highlighted. Every one you click, you're going to add time to it, okay? So we're changing to semi-empirical, PM3, and we're clicking on quasar and hit submit, okay? And so local, hit OK. Alright, so right now it's running. This would take longer. I can't tell you exactly how long. But the rule of thumb is the more atoms and the more electrons it has, the longer it takes. Okay, so a whole bunch of hydrogens aren't so bad because they only give one electron. But if you have bigger elements, iodine or bromine, or if you have transition metals with d orbitals, right, then the time can get much longer. All right, so this came back pretty quick. Hit OK. All right, and so what we're going to do is look at display properties. Okay, you see we have the 2D here. I'm going to go over to quasar, right, and this is where it gives you your quasar, right, some of your values here in thermodynamics. You'll notice that it does not give you anything for bioscores. All right. Alrighty, so this right here again is more of the quasar stuff. All right. Right here you can click on Wikipedia or ChemSpider, and I'm guessing Wikipedia might actually be a little bit better now. It used to be weaker, but this will check to see if this structure has a Wikipedia page. So you can click on that. Give it a second. I know if it's a small molecule, it does it really quick. Yeah, so that it looks for the name label, so we didn't name it, so it's okay. Alright, so C13, we didn't run that, but you can run NMR spectra on this. So that's your 2D drawing. This is what you're going to take for it. Okay, this here is your 3D drawing, so that's your 2D, right under there. This is the quasar data you're going to get, and this is some of the molecule data that you're going to get. Okay. Alrighty. So that's just a real quick thing. When you're done with something, two things: I would hit save, or save as, save it. And then the other thing you have to do before you do your next one is come up here to File and Close. Okay, close it and shut it down. Alright, if you leave it open and you open one on top of it, sooner or later they're going to tangle and it's going to be an absolute mess. Alright, so that's kind of a quick review. Alrighty, so I'm in the classroom right now as you watch this. I'll see you later.